Oh hey guys, Patrick here. So I know that we have looked on this channel in the past at the 5-to-1 or the Fiddle Block system for mechanical advantage, how I use it, how I set it up. But I wanted to come back and just revisit this topic with you guys more in depth. So check this out. I have set up here 6 different 5-to-1 / Fiddle Block systems. Okay, so some of these are pre-made, some of these are kind of cobbled together from random bits of gear. But so we are going to get in depth. We're going to look at what a 5-to-1 is, why we call it that, what a fiddle block is. So let's start with a definition, okay? A 5-to-1 is a pre-rigged mechanical advantage hauling system that you keep ready to go, set up, you keep it hanging in your truck. Anytime you need quick mechanical advantage, you can just pull it out of the truck, set it on the line, and just start hauling on it. And I mean, for me, the 5-to-1 is quite often my go-to in a lot of situations, mostly for the speed of it, but also there's just something to be said for the simplicity and elegance of just an old school block and tackle rope hauling system that I like. So first of all, I often hear confusion about this system. Some people call it a 5-to-1. Some people say no, it's actually a 4-to-1. Some people call it a fiddle block. Some people use these terms interchangeably. So let's take a look at these multiple questions here. First of all, let's take a look at this system here, okay? So this is an old school, I mean, it's brand new, but it's old school design, the concept of the double pulleys to construct a 5-to-1, okay? So first of all, is it a 5-to-1 or a 4-to-1? Well, the way that you calculate the mechanical advantage on a simple haul system like this is you take on the load side, we call this the moving pulley. There's 2 sides of every system. One goes on the anchor here and one goes on the load. So on the load side, you count how many legs of rope are acting on the moving pulley. And that's how we count mechanical advantage. So in a 5-to-1, there are 5 legs of rope acting on the moving pulley, okay? So that's when it's set up properly, meaning that we're pulling from the load end, we're pulling this way. If we were to set it up the opposite way, okay, if we were to set it up backwards, if we were to put the anchor pulley on the load and this pulley at the anchor, well then you can see this would be the moving pulley, this would only have 4 legs of rope acting on it, okay? So if we set it up backwards, it would be a 4-to-1. Okay, so the first question, is it a 4-to-1 or is it a 5-to-1? Well, the answer is both, depending on how you set it up. Now, the way that I define my mechanical advantage systems, again, there's 2 ends. There's a load end, which I refer to as the front of the system, which is also called the moving pulley. And then there's what I call the back end, which is the anchor end, which is the non-moving side. Okay, so with these systems, if you set it up properly so that the moving pulley is on the load end, then it is technically a 5-to-1. If you set it up backwards, then it's a 4-to-1, okay? Now the second question is, why do people use the term fiddle block? Okay, so all of these systems use, on both ends, they use a double pulley, okay? Now a fiddle block is just a special type of double pulley which sits with the 2 legs of rope in line, okay? It's a special pulley that allows the 2 legs of rope to act in line rather than side by side. So a traditional double pulley is like this. The 2 legs of line run side by side. On a fiddle block, they run parallel. They're nested. This inner one is nested inside the other one, and then they run like this, okay? So that's really all the fiddle block is. It's just a different type of a double pulley, okay? So I hope that makes sense. So let's look at the basic elements that go into a 5-to-1 or a fiddle block system, okay? So again, let's go back to this one. This one's easy to show. So first of all, both ends require a double pulley, okay? And then the one of the two double pulleys requires a becket attachment. So a becket is just a secondary attachment on a pulley which is on the opposite side from the main attachment, right? If this is the main, this is my becket, okay? And then a lot of these systems will use a quick link to connect the rope just because it's small. And then most of these, well, all good 5-to-1s are designed for a spliced rope because a knot just is really bulky. And anytime you're dealing with double pulley systems like this, you're going to run into rope alignment issues. So you really have to put a lot of thought into how a system like this is designed so that you can keep the different legs of rope from running on each other. Because anytime they're rubbing against each other, you're generating extra friction and you're really cutting into the efficiency of the system, right? So that is the reason in this situation why you would use a quick link with a spliced line, because it keeps everything nice and small and tight, okay? So you have double pulley, spliced rope, quick link, and then you need some type of progress capture, okay? So there's two main types of progress capture. There's the Prusik loop, Prusik cord, and then there are cam devices. This is an SMC. This is a more traditional over here. A more traditional fiddle block has the progress capture is this soft cam device here. Okay, both of these ones have it, a soft cam. Okay, so those are the basic elements of a 5-to-1. And then obviously they attach with carabiners on either end. And then they also require another Prusik just to place them onto the load line itself, okay? So those are the elements of a basic 5-to-1 or a fiddle block. Now, again, you can purchase a pre-set up 5-to-1, which is what a lot of people do, and several of these here are purchased as a kit. But you can also, once you understand the concept and what goes into a 5-to-1, you can also just sort of put together your own from bits that you have lying around. Now, I already said that 5-to-1s are made from 2 double pulleys. You actually don't need double pulleys, and I'll show you an example right here. This is a way of doing it without a double pulley. So I have a single pulley with a becket, and then off the becket I've run another single pulley which has its own becket, okay? So this is another way of nesting 2 pulleys and then from that creating a 5-to-1. Now on the anchor end here, I have an actual double pulley, okay? So that's one example without double pulleys, and here's another example. This one is made from rigging plates on either end, and then it's just carabiners and micro pulleys. So I'm using the center hole here of a rigging plate as my becket. This is where the rope begins on the quick link. It comes back to a micro pulley, to another micro pulley. It comes down here. This is a micro traction that I'm using as a pulley and a progress capture. This is a cammed device. And then it comes back up to the last pulley, okay? So this is, again, the same concept, 2 pulleys up front and 2 pulleys at the back to create a 5-to-1 hauling system, okay? So hopefully that's making sense so far. What I'd like to do now with you guys is I'm going to take the load cells and I'm just going to take each one of these 6 systems and we're going to hook them up. I'm going to do 2 tests for each of these 6 systems. I'm going to do sort of an unscientific, just me hauling on it. I want to see how much pull I can actually generate on each of these 5-to-1s. And then I want to do an efficiency test using both load cells and just put a known input force into the input of the 5-to-1 and see what that generates on the output, right? So we have 6 different systems. I think we might be surprised at the level of variability between the 6. Okay guys, so before we get into the actual pull testing, I'm just going to show you how I set up and use a fiddle block in the field. So you can think of the fiddle block as having 2 main positions. The first one is the fully retracted position, like this. Fully retracted would be a little further where the blocks would basically be touching. So that's how far down it goes. The opposite would be full extension. So the anchor block and the moving block would be as far apart as possible. And that's what I generally use as my starting position in most situations. The extension available in your 5-to-1 is what we call the travel. So the travel is going to determine how much pull you can actually do with a hauling system before those blocks get right back together and touch, and then you're maxed out, and then you have to reset the system. Okay, so more travel in a system is generally better in tree work, in what we're using them for. So a couple of minutes ago when I was going through all of the different elements of a 5-to-1, I should have also mentioned that the length of the rope in the system is a very important factor. Because the length of the rope is going to determine what the fully extended length of your 5-to-1 system is. So the absolute minimum rope length that you would want for a pre-rigged 5-to-1 system would be around 50 foot or 15 meters. So if the minimum rope length is 50, to be honest, I prefer more. I prefer at least around 70 feet, around 21 meters of rope in my system, just to give me more available travel room for hauling systems, okay? And then the second thing I should have mentioned is that on the end of the rope, so the one end is a splice and it goes on the becket, as we mentioned. On the far end of the line, the opposite end is a stopper knot. You need a stopper knot there so that when you fully extend the system, the end doesn't just pull through the pulley, okay? So hopefully that makes sense. So now I'll show you quickly how I actually go about setting these up. So if we have over here, whoops, sorry, over here, this tree is going to be our load. So we have our load cell and we have this yellow rope, okay? So generally with a 5-to-1, you have your load, you have a rope on the load, and we're going to attach the 5-to-1 to that load line, okay? Now on the opposite end, excuse me, on the opposite end is the anchor. This is the anchor end. So you have options on the anchor. You can just use any old sling to attach the 5-to-1, but what I greatly prefer, instead of just a sling, is actually on a porter wrap, okay? If you set your 5-to-1 on a porter wrap, it gives you more options for resetting to get more pull in your system, and also just as a backup, you can put the tail of your line into the porter wrap. So let me quickly show you sort of what this looks like. I'll just set you guys down here. Okay, so remember I defined the front pulley as the moving pulley that goes on the load side. The opposite end is the anchor pulley. Okay, so I'm going to take the anchor pulley, the carabiner, I'm going to snap it on to the end of my porter wrap here. Okay. The other reason that the porter wrap is really nice for this is that the sling on a porter wrap allows it to float. So it's not stuck on the tree, it's floating. So when it's under tension, it will actually perfectly align with the 5-to-1. And that will be a bonus as well, okay? So this is retracted. I need to start the opposite. I need to start fully extended. So to do that, I'm just going to open up my progress capture. This is actually a little bit easier with a cammed system because all I have to do is pop it out. But with this prusik, what I'm going to do is I'm just going to open it up. I'll just move you guys again here. Okay. So I'm just pulling on the system and I'm operating the prusik, right? And I'm just fully extending my 5-to-1. Okay. Now this particular 5-to-1 actually has 100 feet of line on it, about 30 meters of rope. So in this particular case, I'm not going to fully extend it. It's actually a little bit too big for this space. But usually when I'm using a 5-to-1, usually I'm going to fully extend it before I get started. Okay, so there's one more thing that I wanted to mention for gear on a 5-to-1. I said that we need a prusik cord on the end to attach to the load line. The last thing that I like to use is a micro pulley, and I'll show you why. Okay, so where can I put you guys so you can see what I'm doing? Okay, so I'm just gonna pop the micro pulley off and hang on to it for a second. So what I'm gonna do is I'm gonna take my load line and I'm gonna take the prusik from my 5-to-1 and I'm just gonna do what's called a French prusik, which is you just hold them together and you wrap the prusik around the load line, and just, you want to get a minimum of 7 wraps. Okay, this is just a quick way of tying a prusik hitch. This one's being a little ornery. But anyway, that's what it's going to look like. Hopefully you can see that. Now before I attach the other end back to the carabiner, I'm just going to take my micro pulley, okay, and I'm going to put it on the load line. Basically what I'm doing is I'm making something that's almost exactly like a climbing system here. I'm hoping you can see that. It's okay. I have the load line, I have my prusik cord from my 5-to-1, and I have a micro pulley. And the reason I set it up this way is that at this point, what I can do is I can take the load line and I can just haul backwards like this, okay, to really take the slack out. Okay, so what I'm doing is I'm taking all of the slack out of the load line to get myself to a fully extended position on the 5-to-1. Okay, hopefully that makes sense. So that is how I set up and use a 5-to-1 in the field. Again, porter wrap on the anchor, and then I add a micro pulley on the load line just to really crank the slack out of there and get myself to that fully extended starting position. Okay. So now let's do a test pull here. Hang on. Okay, so now I have done a lot of testing in the past couple of months with load cells of just me pulling on a rope just to see how much I can actually pull on my own. And generally the result has been on good ground with good traction, solid ground, on a rope that I can get a good grip on, I can usually pull between 150 to 170 pounds, just straight pull, okay? So, you know, I would have the tendency to think, okay, well, then I'm just gonna take that, you know, whatever, 150 pounds and just multiply it by somewhere close to 5, and that's what I should be able to pull on a line with a 5-to-1, right? But some of you may remember a video from a couple months ago where I took a 5-to-1 and I just set it up and just reefed on it, and I was only able to generate around 400 pounds, and I was really disappointed with that result. The less friction that you have in your system, so the more efficient your hardware is, it works in the one direction. It helps you to input, so more of your input force is expressed through the system to the output, but it also works in the opposite way, or like friction or the lack of friction is a two-edged sword. So I call it pushback, or pullback rather. The more efficient your hardware is, the more that the load and the anchor are able to pull back and resist that pull. You know what I mean? So that's why I'm not able to pull just what I can pull times 5, if that makes sense. So let's take this system and let's just do the same thing. I'm just going to reef on it, and I want to see with the load cell how much I can actually generate, okay? So all right guys, and then just one final issue that I want to address with the 5-to-1 and how it's set up is that it is attached to the load line, again, using a prusik cord. So prusik cords are designed, well, just the way that they operate is when they are overloaded, they will slip. And I have seen situations where, well, one situation in particular where we were using a 5-to-1 with a big crew, and we were hauling against something. We wanted to anchor it down. It was a storm damage situation. And I think at least probably 5 guys ran over to just reef on this 5-to-1. And as soon as they did that, the prusik slipped. It came down the line. It moved probably about 18 inches or so. This is over 10 years ago. But it almost like welded itself to the line. It melted right onto the load line. And we actually had to peel the prusik cord off of there. So it really damaged the prusik, and it damaged the load line as well. So something to think about with any system that's loaded using a prusik cord is that you can overload it, and when that happens, it's going to slip and it's going to melt. So I would not recommend probably more than 3 people to haul with a 5-to-1. Beyond 3, you can run into the risk of overloading the system. So you can think of it as a feature of a system, is that there is something built in to help you recognize that you are potentially overloading it, because the prusik, without the prusik being able to slip, you could seriously overload a 5-to-1 and not realize it. But the fact that the prusik does slip helps you to realize that you're actually overloading the system, and you need to rethink your setup, okay? Okay, so I'm fully set up with my system. I'm ready to haul. But before I do, I just want to take one quick look and just double check that nothing in the system has twisted. 5-to-1 systems like this have a tendency to sort of twist around once they get under tension. And as I said before, the rope alignment matters a lot. So if there's any twist in the system, you're going to get a bunch of extra rope on rope friction. It's really going to cut into your pull. So just have a look before you actually start hauling, okay? And if there's twist, you have to deal with that and fix it, okay? So this looks good. I'm ready to start hauling, so I want to just see what I can actually, by myself, put into a load cell, okay? Yeah, that's pretty much max. Okay. A couple things I want to mention there. You might have seen how I wrapped the rope around my hand just to give myself a little bit of extra grip on the line. Keep in mind that's super dangerous if you're working with other people. Never wrap the rope on your hand. If I had it wrapped and someone was to come behind me and grab that line and start hauling, I'd be in a really bad spot. It's very dangerous. The second thing is, with this type of prusik-based progress capture, when I am hauling, this prusik is way up here. When I let go, it moves from there all the way down to here. And in the process, it actually loses quite a bit of tension, more than you would think. So I'm sure that's something that we'll look at in the future, progress captures and how they work and efficiency. But all that being said, this is fully tensioned. So I want to see what I can actually haul with this 5-to-1. So here on our load cell, we have 456 pounds, which is 207 kilos. Okay, so as I say, that is not what I can haul personally times 5 or times close to 5. And again, the reason for that, as far as I can tell, is pullback. In a good low friction, high efficiency system, the pullback is enormous. So the resistance to your pull is enormous. So hopefully that makes sense. Now let's do a quick efficiency test on this system and just see what this actually works out to with the 2 load cells, okay? Now I'm just inputting try and move you guys up here. You can see what I'm doing. Okay, so I'm just inputting I'm trying to get as close to 1 kilonewton input as I can, just to make the math easier. Okay. So that's pretty close. Okay. So let's take a look at what this is, right? I have the blue rope 5-to-1 is pulling on the purple rope 5-to-1. Okay, so with an input of 0.96 kilonewtons, my output is, in kilonewtons, it's 4.7, 4.69. Yeah, so it's, everything is fluctuating a little bit, but from close to 1 input to around 4.7 output, that's a pretty efficient 5-to-1, right? That's probably, you know, pretty close to ideal of what you can expect to get out of a 5-to-1, okay? So this is CMI 2-inch double pulleys. This particular one, this 5-to-1 is brand new. I just got it, so it has no wear and tear. It has no like dirt and gunk in the pulley sheaves or anything. This is as good as they get. Okay, so that's why I wanted to do this one first. This was kind of our benchmark. I expect the rest of them as we go to be less than this one, but I don't know. I haven't tested any of these before. Okay, so that's the first one. So let's just keep going here and see what kind of results we can get. All right, guys, I got the second one set up here. Let's take a look. So this is the SMC AdvanceTech HX 5-to-1. I've had this for a long time, and I haven't been using it much in the past few years, but this system, I don't know if you can see it in there, this uses an aluminum cam. It's very efficient, but it's very aggressive, and it actually, every single time that it engages under tension, it damages the line. it damages the cover of the rope. So this rope Probably hard to see on the video there, but this rope is absolutely covered in damage all the way down the length of it. It's just covered in little nicks. But anyway, it is the trade-off for that is that it's super aggressive. So it doesn't, when you let go of input, it grabs that rope immediately and you don't lose anything. So that's the trade-off for that, damaging the rope like that. Okay, so let's see what I can pull, just me on the line here. Okay, so this is a nice 5-to-1. Okay, so that's pretty much tapped out there. Okay, so let's see what that pulled. So that is reading 1.98, 1.97 kilonewtons, 200 kilos, 436 pounds. Okay, so just a tiny bit less than the first one, the CMI there. So let's hook that up with the second load cell. Let's measure the actual efficiency of the AdvanceTech HX 5-to-1. Okay. Okay, so this is the AdvanceTech HX. So with an input of 0.98, I am getting an output of 4.3 kilonewtons. Okay, so that's pretty decent. Let's look at the next one. This is, I think this is the oldest 5-to-1 that I have. This was from WesSpur back in the day. They used to call this a set of 4s. They might still sell these, I'm not sure. But this is just an old school fiddle block with the soft cam. Very simple design, but I like it. Okay, so let's just see what I can haul with this system just by myself. Now, it's hard to see, but one of the reasons that I stopped, I think it's probably the reason that I stopped using this 5-to-1, is that this cam started to slip pretty bad under load, and it's actually slipping right now. So, hard to show that, but I think I'd forgotten that actually. But yeah, that's why I stopped using this unit. I replaced these, but they never really worked properly after that. So using the one-man pull, I'm not actually able to show you totally what I can pull with it because it just doesn't hold the tension. So it stopped out at 1.45 kilonewtons, 149 kilos, 328 pounds. Okay, so unfortunately that test is no good, but the next test will be. We'll do an efficiency test on it. The other unit that I'm using to input the force, the progress capture on that one works just fine. So we will be able to find the efficiency for this old 5-to-1, okay? Okay guys, so here I have efficiency test on this old unit. So if I'm pulling 0.94 kilonewtons, again, the fact that the progress capture isn't working here doesn't matter because it's working down there. So 0.94, so that's 3.99 kilonewtons. So decent, pretty decent. Let's try another one. All right, guys, so I have another unit set up here. This is the Shaefer Marine 5-to-1 that you've seen me use many times on the channel here. Some of you might remember a few months back I put out a video where I just took this unit, I just hooked it up with a load cell, and I just reefed on it to show you how much I could generate with this particular 5-to-1. I think it came out to around 400 pounds, and I was really disappointed with that result. I thought I should have been able to get more. And then it occurred to me that I hadn't actually maintained this this 5-to-1 at all over the years. So I took air compressor to it, and I just tried to blow out all the gunk from the sheaves, the pulley sheaves, and then I took this stuff, liquid wrench dry lube, and I just hit it. I hit all the pulley sheaves with this stuff. This goes on liquid and it dries quickly, so it doesn't attract dirt or anything. This stuff, I really like this stuff. I've actually used this today on all of this hardware that you're seeing for these tests. So I don't know if this will actually make much of a difference in a pull test, but we're going to find out, okay? So let's just take this unit here, and I will just show you what I can generate with this. Okay, so that's pretty maxed out here. Okay, so that's the Shaefer Marine. So we are at 1.75 kilonewtons, which is 178 kilos and 390 pounds. So it appears to not have made much of a difference at all. Fair enough. All right, so let's hook this one up to a load cell, and let's measure the actual efficiency of this Shaefer Marine 5-to-1. Okay. Okay, so this is the Shaefer Marine 5-to-1 with an input of 0.98 kilonewtons. Gives us an output of 4.15 kilonewtons. Okay, so not bad. We have two more to test, all right? Okay guys, so here's the next one. This is the homemade 5-to-1, which is just pieced together from bits that I had. So 2 single pulleys on the front with a double micro pulley on the back. Okay, so let's just see what I can pull with this. Okay, so the way I set this one up is different than the rest. I wasn't sure if this pulley would be any good for minding a prusik, and I didn't think that the Pinto would be either. So I actually put the progress capture at the back, right here. So it's not a very efficient progress capture because it moves this much. So I'm losing quite a bit when I let go of my pull. But it makes for an interesting setup. But let's see what it pulled. So that's 1.56 kilonewtons, which is 160 kilos, which is 352 pounds. So that's not so bad. That's up there with the rest of them, I guess. Let's do an efficiency test on this one. Okay, so with 0.96 input, our output is, 4.36 kilonewtons. Okay, well that's not bad. All right, I have one more to test with you guys. All right, so here we are with the very last 5-to-1 that I'm going to test today with you guys. And this is in many ways the most interesting one that I have ever made. It has rigging plates and single pulleys on both ends. And then it also, one of these pulleys, that's a micro traction, which is a progress capture. It has a cam there, a toothed cam. Okay, so let's just see what I can pull with this goofy homemade 5-to-1. You might be surprised, who knows? I will say that the progress capture on this is pretty efficient, so that's a good thing. And I'm spent. Okay, so that's all I got on there. So that is 1.5 kilonewtons, which is 153 kilos, 336 pounds. Okay, and then the last thing that we'll do with this unit is just an efficiency test. On an input of 0.98, with this thing I am getting an output of 4.24. So that's not bad. Huh. Okay, well, so there's 6 different versions of the concept of a 5-to-1. Hopefully you can wrap your head around, you know, the concept. That's the point of a 5-to-1, is it's a concept rather than a specific implementation. That being said, you know, you really do have to think about the hardware that you're going to use. You can, as I displayed, you can just cobble together a 5-to-1 out of just random whatever you have. But you're going to be better off buying, you know, obviously good, efficient hardware for your 5-to-1, right? I mean, the point of a 5-to-1 is to get a really good pull. So you need the most efficient hardware you can get. So hopefully that video makes sense. Hopefully you can get some value out of it. There's definitely stuff that I forgot or didn't cover or whatever. Let me know in the comments and I will work some of that stuff into more videos. But hopefully this helps someone and gives you some ideas. So yeah, until next time, I will summarize the results in the comments or the description for you guys. But yeah, until next time, peace.